Module 7. In Module 7, we will discuss lean management. Now, the question comes, what exactly do we mean by the initiative Lean Six Sigma? How Lean and Six Sigma, being two different initiatives, come closer? So, what is the idea of lean? Lean identifies risks in the process, how to eliminate those risks from the process, and thereby improve the process. And what is Six Sigma? Six Sigma identifies defects, problems, or variations in the process, understand how to remove or reduce those defects and problems and variations from the process, thereby improving the process. So, one thing is coming clear, which is common between Lean and Six Sigma, that both strives towards improvement of the process. That is how Lean and Six Sigma are coming together towards improvement of a process in every organization. Whenever we talk about lean, there are three major areas that we will discuss. The first one is lean manufacturing. Lean manufacturing, as the name suggests, is mostly applicable in manufacturing organizations. It originally started off around the year 1960-61 in Toyota production system. But we will see that this lean manufacturing, with exceptions, can well be applied in other organizations of different domains as well. There are three areas that we will talk about in lean manufacturing. In Japanese terminology, they are called Muda, Mura, and Muri. What is Muda? Muda means identification of waste in the process, how we can eliminate those waste from the process and thereby improve the process. What is Mura? Mura means identification of inconsistency and inefficiency in the process, how we can eventually eliminate those from the process, thereby improve the process. What is Muri? Muri means identification of excess stress within resources within your organization, which are part of process, how we can eliminate those excess stress from the resources and improve the process eventually. Here, resource does not mean only human resource, it means machineries, furniture, etc. as well. In Muda, there are 8 kind of waste which we can identify. Number one, defect. As I said, defect is not necessarily identified only in a manufacturing organization. It can be identified in other organizations also. Overproduction. Overproduction is a typical example of manufacturing organization alone. Waiting for work, idle time can be applied in other organization, any organization per se. Not utilizing talent, you have recruited some very skilled resources or some very high cost machineries with the expectation that some work will start, but it is not starting. So you are not able to utilize them properly. It's nothing but a rest to the process. Over transportation, which can happen in a manufacturing organization. Inventory excess is a result of overproduction. Ideally, could be applicable only in manufacturing. Motion or movement west of employees from one department to another, unnecessary movement and excess processing. Now, out of this 8 kind of waste, number two, overproduction, number five, over transportation, and number six, inventory excess. These three are typical examples of manufacturing organization. There is a terminology in lean manufacturing. In Japan, it is very well used, which is called jidoka. It simply means where machines automatically stop working upon detecting an abnormal condition and operators try fixing the defect to prevent recurrence of the issue. So in that case, what happens? No faulty output is created, no defects or wastes are created from the machinery. The second area that we are going to discuss is lean generic principles. Green generic principles, as the name suggests, it can be applied in general in all kinds of organizations. There are 5 P's: value, that the company delivers the most valuable product to the customer. The customer should always have a value for money. Value stream, identify within the process those stream of activities which creates that value items. Flow, your organization process should be such that it should be free from any interruption, inefficiency, bottlenecks, hiccups, etc. It should be like a symphony. It should be like a symphony or music, that it starts and ends, the process will go on in a complete flow. Pool management. Pool management means produce only that much that is required by your customer. But for this, good amount of customer facilitation, customer management, and customer planning is required. So in that case, you don't have much or no waste at all in the organization. And perfection. Produce everything to the utmost satisfaction of the customer, which is called the perfect scenario from the quality standpoint. The next area we discussed is the Lean 6S philosophy. In the Lean 6S philosophy, we talk about 6S. First one, sort. The word in the bracket is the Japanese terminology. Sort. Items of the similar nature are always stored or kept at one place. That is called sorting. Set in order. Just keeping in one place will not help. You have to keep those in a proper order, based on size, based on wattage. Because of this, you have to keep those in separate boxes at one place, but a bit isolated and separately kept. That is called set in order. Shine. Every organization that you work for should be kept cleaned and shined for the employees and for the customer. Standardization. Whatever way you start, whatever way you set in order, and whatever way you shine, is standardize the process. That is, every day in and out, you always use the same process, so there is a consistency in the performance. And we always say that process is the best process, where there is a consistent approach from all corners. Sustain. Whatever way we have sorted, whatever way we have set in order, and whatever way we have shined and standardized, please sustain that. You remember, in Six Sigma, we talk about continual improvement, that is, doing an improvement and sustaining it. It is the same over here in Lean, that whatever you do, please sustain so that the process becomes a permanent process. And eventually, safety. Safety is first for employees as well as for customers. Lean and Six Sigma perfectly complement each other. While Six Sigma employs tools, Lean applies principles. Six Sigma tools can be used independent of one another, but whereas Lean principles are best used together. That is, whether it is 6S philosophy or Lean manufacturing or generic principle, try to use together to get the best out of it. Some case studies. If you remember, I have already discussed this, that in any Six Sigma initiative, whatever we have learned till now, it is not really that whenever you actually go for doing your Six Sigma project, you will be able to do each and everything that we have learned. Your situation might not allow you to do it. We might have learned 30 areas. You'll be able to apply only 10. So this is one example from a Malaysian RO company, which is a government organization, where I will show you, with the help of only some selected tools and techniques, they are able to do a successful Six Sigma initiative. There are some confidential clauses because of which they haven't disclosed everything. But if you see, if you come to the fifth paragraph first, they had originally in the performance level of 2.97 sigma. That means the original sigma they had is around 3, which was not making the management happy. So what they did, come to paragraph 2, they did a process capability calculation first to find out the sigma value. Then paragraph 3 states they started the Lean Six Sigma initiative in a very unique way, starting with an West analysis. That is, what are the different Wests that we have in our process and how to improve that. Eventually, followed by the improved process capability to showcase how process capability has improved, how the Sigma value has improved. In the course of the process, they have also done the failure mode effect analysis. And we have learned that failure mode effect analysis is done ideally after the improvement plan and the implementation plan. So only with process capability before and after, West analysis, improvement plan, implementation plan, and failure mode effect analysis, that is the risk management plan, this organization did a successful Six Sigma project. Of course, they haven't displayed what was their final Sigma level, but that's okay. So definitely, they have definitely achieved maybe 5 Sigma or 6 Sigma, whatever it they could be. The second case study that we discuss is from another Southeast Asian country, Indonesia, where they also did a Lean Six Sigma initiative and they identified the 8 kind of West as stated in the third paragraph. They also started with an West analysis. They in all had 11 CTQs. It was a big chunk of project actually. And what they did in the course of activities, they did a cause and effect analysis, YY analysis, Pareto, and eventually after the improvement and implementation plan, they did an FMEA also. Eventually, they did a Sigma capability calculation again, and finally they achieved 4.54 Sigma. It could be understood that their original Sigma level, which they haven't announced, original Sigma level could be around 1 or 2. It was so horrible. That's why they did all this Six Sigma Lean Six Sigma initiative and finally achieved 4.54 Sigma. Because we have learned earlier that whenever you do a Six Sigma initiative, it is not mandatory that you have to always attain Six Sigma level. If you can, that's wonderful. That's the ultimate. But at least from the original process capability in the measure phase, you have to ideally reach at least 2 or 2.5 sigma higher, which will indicate that you have done a fair amount of improvement. Okay? With this, we come to a close of module 7. Further discussion we will have in module 8. Thank you. Module 8. In Module 8, we will discuss project closure and some other related items. Now, after the project has been successfully completed, that is, all the 5 phases define, measure, analyze, improve, and control are successfully done. There is a formal process, ideally, which needs to be followed to close a project formally. First step, ensuring good controls, which we have already done in the control phase through a proper control plan and ensuring that proper control methods are already applicable. Then controller sign off. Controller sign off is ideally the finance controller sign off. That is, ideally, after a project has been successfully closed, a mail or a minutes of the meeting from the CFO or any responsible person from the finance department should indicate how much savings this particular Six Sigma project has given to the organization. Process owner handoff, that is the sponsor handoff. After a project has been completed, that means the process has been improved. This process has to be officially and formally handed over to the process owner or the sponsor, who is the departmental head of the process. Leverage the project. Leveraging the project actually means or record the project. Both record the project. That is the last one. If you see record the project and leverage the project. Record the project, I will talk first. Record the project means in many organizations, there is always a common platform like knowledge management platform, learning management platform, common server, where many documentations, many good practices, best practices are always updated or uploaded so that people can refer to those and learn. Similarly, there could be a place called Six Sigma where all the project documentation and the outputs could be recorded over there, which would help as a leverage to other people because a Six Sigma project is very much a reusable component. That is, whenever a person does a Six Sigma project, he or she could take a learning from the earlier projects that has been done and plan his or her own project accordingly. Lessons learned. Lessons learned basically talks about that whenever a project is closed, you can prepare, you should prepare a lessons learned or a project closure report stating what are the good things that you have done, what are the things you could have done but you could not do for some reasons, what are the challenges you have faced, how you have overcome those challenges, what are the risks you have faced, and how you have closed those risks. Those could help you for your further projects, after projects, and also it can help other people who wants to do their own projects. So that would serve as a leverage or learning for them. Sponsor closure. After all these formalities are duly completed, the sponsor could now successfully and officially close the project, marking the project as closed. At this stage, you can try to receive any appreciation mail from the customer stating that whatever he or she was asking for, you have already given that. So that would serve as a good measure for the sponsor to close the project, followed by a small celebration to mark the end of the project. Whenever we talk about Six Sigma as a project, we talk about preparation of a sample documentation. Now, a sample documentation for a Six Sigma project ideally would be a PowerPoint presentation. So I would always recommend that whenever you do a Six Sigma project, you should open a PowerPoint presentation where the first slide should ideally state the project title, the one liner. The same project title which we have defined in the project charter originally, in the define phase, should come over here. After the project title slide, there could be two or three slides exclusively for the define phase. The first phase for define could include your VOC, CTQ, and the specification limits, and how from the VOC the CTQ has been derived, and from the CTQ how the specification limits has been derived. Your next slide on define phase should ideally be the project charter. You can do the project charter work in an Excel format, copy and paste it on the presentation. Same with the SIPOC analysis in the next slide, followed by the define toll gate checklist and the details of the checklist, how you have performed. This is one example of a project charter, another example of a SIPOC analysis. In the sorry. In the measure phase, the first slide should ideally include a detailed process mapping, value-added activities, non-value-added activities, value-enabling activities, followed by another slide with the data collection plan, the process capability, whether you do it in the CPK or in the DPMO way, whatever way, you do it on Minitab and copy the Minitab output and paste it on the presentation slide to show the process capability. Measurement system analysis probability distribution as applicable, you can do on Minitab and copy and paste the output over here, followed by the measure phase toolkit process and checklist. This is one sample measure phase, detailed process mapping. For the analyze phase, the first slide should ideally include the brainstorming results, that is, the actions coming out of it, the root causes coming out of it. You can jot it down, followed by the second slide on the cause and effect analysis, and subsequent slide should be on the why analysis for all the root causes that you have jotted down in the cause and effect. Pareto analysis as applicable. Pareto analysis, hypothesis testing, correlation and regression, as the case may be. Do it on Minitab, copy the graph or the chart from the Minitab, the output from the Minitab, and paste it over here in a separate slide. Don't put too many things onto one slide to make it more clumsy. Put one subject in one slide so that it becomes good readable, followed by the analyze phase tool gate process. This is one sample cause and effect analysis. In the improve phase, improvement plan and implementation plan subsequently, followed by the risk management plan, solution selection metrics, after improvement data, 7 management tools, if applicable and as applicable, Porter's 5 forces you can put over in different slides to the extent applicable or done by you. Design of experiments, if done, the Minitab output you can showcase over here. Before and after scenario is compulsory to be shown in a slide, followed by the improve phase toolkit process. In the control phase, your first slide should ideally have the control plan or the improvement sustenance plan, followed by the control methods, Okayoki or SOP, as applicable, as done. You can put it on the slides, followed by the statistical process control, project learning reporting. You can document over there, project closure formalities, as we discussed, final closure with a vote of thanks, and the final slide will be on the control phase toolkit process. Lean, whatever is applicable, lean manufacturing, lean generic principles and success philosophy, or identification of the 3 Gs. Whatever you want to do or you have done for the lean initiative in your organization, if any, put it under subsequent slides. There is one project assessment which I, in my virtual session or in my classroom session, I expect people to do it. If you could be interested, you can get the assessment one Excel sheet from IMC and do this project assessment, which is a sample small kind of Six Sigma project, I will say, which you can do with a live example from one particular area. Modular questions. Some modular questions to prepare you for your exam finally. The analyze phase of the DMAC, the process has the characteristic of answer C is the right answer, establishing relationship between X and Y. Measurement system analysis talks about option D, measurement variation. Engage R&R, which one will be the correct answer? It is option A is the right answer. Repeatability means same person, same data, same measurement unit, and how much is the variation. In a continuous gauge R&R, the result shows about what? It is the variation percentage. So option A is the right answer. In case of discrete R&R, the result shows about the accuracy percentage, option B. In gauge R&R, generally, there are two methods of measurement. Which two are the right answer? It is crossed and nested, if you remember. Crossed at the same time if the measurement is done, at different intervals if the measurement is done, it becomes nested. So option B is the right answer. In gauge R&R, which one will be the correct answer? I just discussed this. So both A and B are true. Option C is the right answer. What is a process? Option B, a collection of activities done in an order to result in a product or result. In a root cause management in analyze phase, important components are brainstorming cause and effect and why. Option A. Gauge R&R talks about very easy, repeatability and reproducibility. Answer A. Option A. Control phase deals with majorly two things: control plan and control methods. Option A. Process capability for continuous and discrete could be determined. I think this is also very easy. Option A, CPK and DPMO methods, respectively. Six Sigma is about quality, while Lean is about option D, increasing speed and reducing waste. In a correlation analysis, which option will be the right answer? Option A. We find out the mutual and co-relationship between two sets of data if positive, negative, or no correlation. Why we consider lower of the two CPU and CPL while deciding on the CPK value? Because lower value is the safest and ideally tenable. Option A. In order to calculate DPMO for discrete process capability, the following ingredients are necessary. I think this is also quite easy. Defects, units, and opportunities. Option A. Regression analysis talks about both A and B. Dependency of X data on Y data. How much Y data changes with X data? So option E is the right answer. What is the key concept of the Six Sigma Code philosophy? Option B. Six Sigma is a business improvement methodology that seeks to find and eliminate causes of defects and errors. The sigma shift of 1.5 sigma is basically the difference between Z short term and Z long term. Option A. In probability distribution, binomial and Poisson distributions are respectively for binary and count data. Option B. The difference between other types of hypothesis testing and one-way ANOVA is option A. ANOVA deals with more than two data sets. In a two-way ANOVA, we deal with option A, that is effect on Y data and also the interaction effect sense. The objective of design of experiment is option A, to verify the vital few X's that impact the quality of project Ys. In DOE, design of experiment, it is important. Option A, to determine the test levels of each independent variable. Levels are always two. In DOE, the experimental trials table shows option A, the combination of levels and factors. What would be the number of trials? In DOE, the results that we present are option C, main effect and interaction effect. In DOE, the conclusion actually states option A, which factor has the main effect on the problem and also the interaction effect between factors. In DOE, a full factorial DOE is practical when fewer than 5 factors are being investigated. Testing all combinations of factors levels becomes too expensive and time-consuming with 5 or more factors. True or false? Answer is true. Option A. X bar R chart and IMR chart are for continuous data. Option A. In hypothesis testing, we start off with identification of null hypothesis. Option D. The difference between one-way ANOVA and other tests in hypothesis testing is ANOVA deals with more than two data sets. Option B. Between specification limits and control limits, there is no statistical or mathematical relation between them. Option C is the right answer. Control charts could be drawn. Control charts could be drawn for both continuous and discrete data. That is option C. At what stage of the process should the presentation of information analysis and statistics to the business come? Right answer will be all the above, option E. In a hypothesis testing, we try to identify significant difference between data sets, option A. A measurement system analysis is designed to assess the statistical properties of gauge variation. Option A. Which of the following activities is value added? It is option B, that is process. In order for a problem to be solved correctly, which of the following must occur first? The problem must be defined, option A. Typically, which of the following actions is not used, C, not used to reduce process cycle time? It is option D, implementing activity-based costing. Which of the following tool is commonly used in the measure phase of a project? Data collection checklist, option D. In DOE, the first step always is to define the problem, option A. In DOE, stating the hypothesis means identifying the factors that is affecting the problem, option B. In DOE, always we have to identify the dependent Y and the independent X, option B. In brainstorming session, you do what? You identify the root causes or the major value drivers, option A. In detailed process mapping, there are three components. Option A, value added, non-value added, and value enabling activities. A relationship diagram is used to signify the strength of relationship between two processes or sub-processes or entries, option A. With this, we come to a close of our Lean Six Sigma Black Belt training. Thank you very much for your attendance and goodbye.